Hey, what's up everyone? Welcome back to the channel. In this video, I'm going to show you how to connect a BME280 to a Meshtastic ESP32 LoRa board and send live temperature, humidity, and pressure data over a private LoRa mesh with no Wi-Fi and no internet. Now, LoRa is a low-power wireless technology that can send small amounts of data over several kilometers, which makes it great for remote sensors just like this. In this tutorial, we will wire everything up, flash the boards, set up a private channel, and verify the telemetry shows up on the second node. So this is a pretty interesting technology if you are in the IoT space, and I suggest you tag along. Even better, before we get into the tutorial today, we have the free blog on shilleh.com, which contains the steps and instructions in more detail. So if you don't feel like writing the commands off the screen, or you just need a little more help, you can follow along on the free blog in the link down below at shilleh.com. Also, be sure to like, comment, and subscribe, and let's get started. Okay, so the first thing we want to do is we want to install the Meshtastic CLI tool in our Python virtual environment. Now, this is a tool that lets us configure, inspect, and control our Meshtastic LoRa devices as you see here, which will enable us to run commands and set up the network and see if our devices are working as expected. So make sure you have Python installed on your computer, and we could just run these commands in any terminal. And of course, go ahead and set up an empty project where you can create your virtual environment. So I'm just gonna go ahead and copy these commands. And you can see I just went into Visual Studio Code, which is just an editor. And I already have the Meshtastic environment. We can go ahead and run it again. So what this command is going to do, first it's going to set up a virtual environment which has your Python packages. Then we're going to source it, which enables us to have access to those packages. And finally, we're going to install Meshtastic. So I'm gonna go ahead and enter this. And because I already have it, you can see everything's already satisfied. So once you have this, you have your environment, and we'll be using this later on to interact with our Meshtastic devices. Okay, next thing we want to do is we want to install the Meshtastic firmware on each device. So we could just use the web installer. Be sure you connect each device to your computer. So I'm just gonna go ahead and connect this first one. It already has Meshtastic on it from before, but we can go ahead and reflash it. So go ahead and just open this, flasher.meshtastic.org. And then we can select the target device. So all the instructions are back on this page. Click connect and choose the serial port. So it's going to, let's see, auto detect. I actually never tried this feature. Okay, cool. So I believe this is the correct one. So on a Mac, it's cu.usb 001. So we can go ahead and connect this. I'm going to dismiss that. And I believe this is the Heltec V3. So I'm just go ahead and double check. Okay, so Heltec V3, so that's the one I got from Amazon. That is linked in the blog. So we have the Heltec V3. We're going to use this beta version as you see, and we're gonna go ahead and flash the firmware. So all this stuff, we don't really care. Let's actually see something. Let's go ahead and continue. Okay. So ensure your device is connected. Looks like it's good. Flash and erase. We want to do that because we want to start from scratch. One thing I want to see is if there's actually other versions here. Let's actually just use the stable. That's the unstable version. Stable or, okay, so stable or beta is actually the stable version. So I just want to make sure, because usually beta is the unstable version. Anyways, let's go ahead and flash this. New contributors. I don't know what's going on here. Let's go ahead and refresh this page a little. Slightly buggy, it's okay. So once again, Heltec V3. So the beta version, flash, and continue. So that continue button is there. So let's go ahead, full erase and install. Baud rate is fine. And we can go ahead, erase and flash. So go give that a moment. First of all, pair it here. And that should begin to flash. So once this is done, we should see a success message, and then we could do the next device. Okay, so it looks like the device is done installing, and we can see on the screen, this little device has a screen here, shows that it's successful. Let me go ahead and zoom in onto that. And you could see we could just go ahead and click OK. So we could just hold the top left button there. And once that's done being held, we'll see that there are some other messages on the screen here. And there's a back button, there's US. Let's go ahead and click the button. Every time you click it, you can go to the next option. So I'm just gonna go ahead and select US as you see here. So go ahead and hold that button now. And I believe in different regions, it broadcasts a different type of frequency, but we're in the US. So I just select the US frequency. So it's rebooting. And that should be good for this device. And pretty much what we could do now is once that's installed, we could do the same on the other device. So once again, go ahead and go through the CLI tool, make sure the device is connected to the computer, and install the firmware on the other device. Once again, click through the options on the screen and select US. If you are in the EU, select the EU option. And there you have it. You have the Meshtastic firmware on the device. Followed by this, we're going to run some Meshtastic CLI commands that we'll be interacting with on the device to create the channel and prepare the device for telemetry. Okay, actually before we run these Meshtastic commands, what we want to do is we want to wire the BME280 sensor. So I have the wiring here. I don't have a direct wiring diagram, but I show you which pins to connect. So we have the BME280. We want to connect these 4 pins. So these are for communication and these are for power and ground. And we want to connect them respectively to the Heltec V3 pins like this. So these 4 pins, so just take 4 jumper wires and connect them. And you can see all those pins are on this side right here. So we have the 41 and the 42 pin, I believe. Yep. And then we have 3.3 volts and ground. And I also labeled the pins here. So you only need these top 4 pins. And the Shilleh BME280 comes pre-soldered, so you can just plug it into the breadboard as you see here. And that's how it will look when it is connected. And you can see that in real life. So this second board, as you see here, actually has those connected like that. And that's pretty much it. So now this thing is ready to start reading from the BME280. Okay, so jumping back to our Visual Studio Code, make sure you have the virtual environment activated. And the first thing we're going to do is we're just going to connect to board 1 to keep it simple for you guys. And on this board, pretty much what we're going to do is we're going to set up the network, set up the encryption key, and get the private channel URL that we're going to feed into board 2 to allow other nodes on the network to communicate with one another securely over the private LoRa mesh network. So we're just going to run a series of commands. Once again, all these commands are available on our website. So here are the commands here. So it just connects to the port, it creates the channel, creates a private key, and it sets the region and commits it to the board. And finally, once it's created, we're going to get that primary channel URL because we need to pass that into the second board, which is the board with the BME280 on it. You can see the board right here is not in the breadboard right now. We don't really need a breadboard, to be honest, because there's no sensor on it. But this board is what's going to be retrieving the telemetry data from the other node within the network. So we can go ahead and click enter here. And before I do that, you may be wondering where I got this port here. I'm on a Mac, so you can simply get this port. If I open a new terminal right here, you can do ls, and then you could do dev cc USB URL, or USB serial, sorry. So let's just do ls this, and we could do star, and then you can see that the board is connected at this port specifically. Windows and other operating systems have a different format, so go ahead and search that on your own. But for a Mac, this is the port for this board. So once we have that here, we can go ahead. Let me just zoom in here to the commands. Once again, all these commands are on the website for free in the link down below. And we can go ahead and click enter here. So give that a moment. Okay, so it looks like we have the channel URL as you see here. Now let's just go ahead and run a reboot. It's typically good practice after we do a large configuration change just to run a reboot to make sure things are working as expected. And let's go ahead and do that. And once we're running the reboot, you should see on the screen on the device that it says rebooting. So just give that a moment to reboot. And then once that's done, let's plug in the second device with the BME280 and configure things on that device. Okay, so second device is plugged in. First device is no longer plugged in. This device has the BME280. So we're just going to configure the private channel URL we got here. So we're going to set that, and we're going to set a few other parameters in terms of the telemetry as you see here, and then we're just going to reboot the device. So we can go ahead and just paste these commands. Once again, all these commands are on the Shilleh website. So first we set the channel, we set the region, we set the telemetry properties, and then we just reboot. So go ahead and click enter here. And in a few moments, you should see that the device begins to reboot after all these commands are registered on the ESP32. Give that a second. Okay, cool. So telemetry configuration is done. And rebooting once again, so you should see on the screen rebooting. And that's it for device number 2. Let's actually go back and run one more command on device number 1. Okay, so the last command we have to run on device number 1 is we just have to run the set telemetry environment screen enabled just to show the telemetry on the screen for device number 1. Forgot to run that. Just go ahead and plug device 1 back in, click enter. And that's fine. So everything's ready to go in terms of the settings. Now, because I don't have enough wires to connect to my MacBook Air, which only has 2 ports, I'm going to go ahead and actually unplug one of these and connect it to a battery which comes with this version of the ESP32. So this version you see right here, the first board, I'm just going to plug it into the computer. And the other version right here, I'm going to plug into a battery. So this is board 2 with the BME280. So I'm going to plug a battery in the back of the board. And what that's going to do is it's actually going to power it on, and we don't have to have it connected to our Mac. If you see the tutorial on shilleh.com, we don't do that. But because I have a bunch of things wired to my computer right now, I have to connect one to a battery. But pretty much this is fine as long as it has a power source and all of your parameters are configured on that device. You should be able to power these without your computer. So keep that in mind. You really don't need your computer at this point. You can have an off-grid network as long as these things are within range, that is a few kilometers of one another. They can receive signal as long as they're powered on. So let's go ahead and attach the battery to this device right here. And we'll go ahead and make sure that the board 1 is receiving information from board 2. Okay, so now that we have everything connected, you see I have board 1 plugged into my computer, and now we have board 2 here. As you can see, now it's plugged into a power source, just a battery. So what you should typically do is just plug it into the battery or plug it into the computer, even if you like, that is a power source. And you want to separate them at least maybe by a foot, because LoRa works better by a foot or more. Really, it might work close, but just keep them a little distance apart. So I'm gonna go ahead and move this over. And what you should see is after some time, maybe 30 to 60 seconds, the telemetry will be transmitted to the other board as you see here. So I'm just going to go ahead and show you this. So this is the environment section of the board. And you can get to the screen, or you can move away from the screen by clicking this button as you see here. And you can go back to the telemetry section on the board. So I believe it's this screen right here. And this updates periodically, I believe about a minute or so. And that's pretty much it. So the other board is sending that information to this board right here. And of course you can have other boards in the network, and you can go around and play around with this. You can use other sensors if you like. The BME280 is the only sensor I've experimented so far with this board. It's pretty popular because it can measure environmental data and temperature, pressure, and humidity, things you would use in an agricultural project, which is really where a lot of these LoRa modules are used, in open environment projects where you don't have access to internet or Wi-Fi. So pretty cool. I think it works as expected. So if you got this working, please be sure to like, comment, and subscribe to the channel, and be sure to check out the Shilleh blog on our website, along with other components related to the tutorial today, such as pre-soldered components that you can use to make your projects a little easier. In addition to that, we have other components for Raspberry Pi, Arduino, and all sorts of IoT projects that you guys can check out. If you want to see anything new, let me know in the comment section down below, and feel free to reach out on our website as well in the contact section if you have any questions or want more advanced help in your IoT projects. Thanks guys, and I will see you in the next tutorial.